Hello, welcome to Latency Exchange. On this channel we discuss technical topics relating to low latency trading, concentrating on the exchange side concepts, technologies and processes. I'm Dave Beattie, a solutions architect specializing in low latency exchanges. In this first series of videos I will detail my architectural solution for a 24/7 low latency exchange. In this video I will detail the zones that comprise the architectural solution. I will focus on the general contents of each zone and its structure as relates to the overall solution. I will also provide details of the communications that pass between each zone and the security measures that can be taken to control this communication. There are 4 zones in this solution. The core zone is where the low latency trading happens. The back office zone is where the remainder of the exchange functions happen. The management zone is where all platform and exchange management and monitoring happens. The external zone is the rest of the world from the platform's point of view. I will start with the external zone and then work back up through the architecture. The external zone is considered the rest of the world by the exchange platform, but this is clearly not a single entity. It is expected that standard defenses will be in place to protect the corporate network from external attacks from the Internet and other public access services. Standard internal defenses should also be in place to mitigate attacks and intrusion. The technologies that support these defenses evolve at such a rate that I do not propose to go through them here. The external zone may only communicate with the management and back office zones. I will now go through the communications and how they should be secured. I will also detail a solution for a DMZ-based file transfer service. This is an overview of a secure file transfer service that will support safe transfer of files from one zone to another. At this stage it should be noted that not all of the monitoring components are necessary for this to work, but they can be added in a variety of ways based on the business and technical requirements. Firstly, we need to define some operational rules. The file transfer server is the only active part in this solution. It must pull files towards it from a source in one zone and then push them away to a destination in another. Between these two operations, it must complete whatever scanning or filtering it has been tasked with performing. This sanitization service might include virus scanning, sanity, format, and semantic checking. Once the transfer is complete, the source files and any transit copies should be removed. The final rule is that all components in this solution must only be configurable via dedicated management interfaces. This is to mitigate any management side vulnerabilities. The servers should have separate interfaces for the internal and external legs of the file transfer, with a specific routing table, i.e. no default route. And routing of packets from one interface to another should be disabled. The network taps should feed into a monitoring service that is able to alert and take action based on suspicious activity. Here are a couple of examples of how this file transfer solution would operate. The exchange needs to send a T+5 minute price stream to a public internet server. The following flow is observed. The back office systems generate a real-time price stream, and from there a delayed price stream is extracted to a handoff directory. The file transfer service pulls these files and puts them into an internal verification directory. It then performs whatever verification it has been instructed to and leaves the files in a transmission directory. The file transfer service then pushes these files to a corporate or DMZ server because it does not have access to the internet itself. Finally, the DMZ server transfers these files to the internet service. In the second example, the exchange needs some external data, say FX rates, from a service provider over a private line. A DMZ server receives the data from the provider via a multicast feed. It segments the data into tick files and makes them available in a handoff directory. The file transfer service pulls these files and puts them into an internal verification directory. It then performs whatever verification it has been instructed to do and leaves the files in the transmission directory. The file transfer service then pushes these files to a back-office reference data server for onward use. Connectivity between the external and back-office zones should only be for automated processes. In this way, a file transfer service is able to securely move files between these zones. No interactive sessions should be permitted across this path. The path can be used to move data feeds between the environments, such as rates files and external data, with a secure file transfer service providing the transfer mechanism. Connectivity between the external and management zones not only offers a secure data transfer service, but also needs to offer interactive access for operations teams to be able to manage, operate, and monitor the Exchange environment. The secure file transfer service operates in the same way as it did before, but the files might tend to be larger in size. These could include backup files, log files, build files, and reporting. Interactive access should be in the form of remote console or remote desktop solutions, with file transfer capability disabled. This ensures that all data within these sessions remains within the management zone and is not allowed to leak into the external zone. One challenge for this architecture is the ability to provision live monitoring services to operations teams. This is most easily achieved by putting the monitoring service in the management zone and replicating output web pages via the secure file transfer service. The back office zone has a traditional structure with dual paths for all services and servers. This means that standard firewall, load balancing and storage solutions can be used. Clustering and database solutions can also be used where required. Solutions should be appropriately sized to cater for peak loads. Single points of failure must be avoided, and applications must allow for convergence times of 1 to 2 seconds. External data feeds are permissible, as previously noted. However, not only must the Exchange be protected from incursions from these services, but there is also a duty of care to prevent such services impacting each other. Hence, separate DMZs and Bastion hosts should be used, even if they're virtual. It is accepted that the short-term loss of a service in this zone will not prevent the trading in the core zone from continuing to function. Interfaces in this zone should be reasonably low latency to support rapid exchange over chatty protocols. The structure of the management zone is similar to the back office zone, with traditional levels of resilience and convergence. There is likely to be a separate secure section of this zone to support time services. We will go into this in a later video. All servers in the environment will have an interface in this zone. It does not need to be a particularly low latency interface, but needs to be fast enough to support the transfer of large files as previously detailed. Wherever possible, this should not support a default route, and it would even be advisable to run a security service on this interface, either a host-based firewall or a layer 3-4 security service like IP tables. Servers that are based in different zones should be on separate firewalled subnets in the management zone to prevent any cross-connection risk. Further segmentation and protection may also be used. The connectivity shown in this diagram is generally prohibited. Direct communication between the external and the core zones is not permitted due to the inherent security risks. Connectivity between the management and back office or core zones is also not needed because every server in the back office and core zones will also have an interface in the management zone. This is where things become a little less conventional. In order to support the failover requirements needed for a non-stop 24/7 service, components are not just duplicated, but are quadruplicated. This means that each function is supported by 4 servers residing on 4 isolated switches. There is no shared storage because this would also need to be quadruplicated in order to support maintenance cycles. To promote clarity, the diagram does not show the full set of servers needed in the core, nor does it show the full set of links. This solution does require a large number of network links, and careful management of these is a significantly complex task. Later videos will go into how all of this hooks together to support the failover requirements. The final zone, which is arguably part of the management zone, is the packet broker network. This takes tapped or redirected feeds from the many locations shown in the previous diagrams. It manipulates them as needed, aggregates them, and sends them to the various consumers that form part of the monitoring or security stacks. It does not need to be low latency, but needs to be able to handle the data rates experienced in this environment. It also needs to be able to buffer packet streams under microburst scenarios due to the duplication and synchronization of many of its feeds. Optionally, external services may be used to deduplicate packets and to decrypt them in order to reduce the load on its consumers. The number of inputs to this scenario will depend upon the business requirements, but it's certainly conceivable that all links in the core zone and all external facing links would need to be tapped. There is no direct connectivity between the core and back office zones. Any data that needs to be moved between these zones must be moved by data extractors and injectors. These work similarly to the secure file transfer servers, but they have a few key differences. There is no firewalling for this service. All hosts are assumed to be trusted. Because these servers exist in the core zone, there must be 4 of them. Data extractors are responsible for extracting data from the core zone, and the injectors are responsible for injecting it into the core zone. Extractors and injectors can reside on the same host, but run as separate services or processes. Extractors and injectors can forward data streams, not just data files. The next video will look into the internal communications within the core zone, showing how resilience is achieved and how it is used to support 24/7 operations. Thanks for watching. Please leave any question in the comments and I will reply to them as soon as I can.